For the first talk, you have AI, you have deep learning as some of the key concepts that I hope a lot of our audience members are excited with. And to deliver an interesting lesson or lecture on this is we have Dr. Charibeth Cheng. She is the Associate Dean of the College of Computer Studies and one of the senior researchers at the Center for Language Technologies. She is also the co-founder and head of research of Senti AI, one of the pioneer artificial intelligence companies in the Philippines. Dr. Chari specializes in the area of natural language processing and machine learning. At DLSU and Senti, she and her engineers and students work on developing computational models, tools, and electronic resources that will make machines process, understand, and generate text written in our local Philippine languages. Her research and publications are focused on the areas of artificial intelligence, data and text analytics, language processing, and related interdisciplinary area. Without further ado, I give you Dr. Charibeth K. Cheng.
Thank you, Doc Shona. Can you see my slides?
Yes, we can, ma'am.
Okay, so let me just minimize this. So happy to be here. Thank you, Doc Shona. Thank you, Doc Angie, for inviting me. So my talk today is about transformers, specifically on their ability to create. Before I proceed, I just want to make sure that it's clear that I'm not talking about the Decepticons and the Optimus Prime. These are AI transformer models. And when I gave Doc Angie the title of this presentation, I thought it's going to be a sexy topic. But as I was preparing the slides last night and reviewing them, I realized that nobody might find that presentation nice. So this is what I will do today. So I will use the chatbot to show a journey that led to transformers. So this is not the history of transformers. This presentation is meant to provide an appreciation of how transformers solve the limitations or the difficulties that we encountered when using the earlier AI techniques. So meet Eliza. So this is Eliza. She is one of the first, if not the first chatbot. It was developed in MIT labs in the 1960s, I think between 1964 to 1966. She was developed by Joseph Weizenbaum. She is meant to simulate a Rogerian psychotherapist or therapy that is patient or client-centered. There are many implementations of Eliza on the internet, so you could just Google them. And as you would see from this conversation that's happening on the video, Eliza is usually just parroting back what the user is saying because it is a Rogerian psychotherapist. So that is patient-centered therapy. So by the way, this is not the actual Eliza app. So this is simply a rendering of Eliza, the way we now use chatbots. So the conversation that you see here is actually a transcript of the conversation with Eliza as found in the 1966 paper of Joseph Weizenbaum. There are many implementations of Eliza on the internet, so you just Google it. Okay, so how does Eliza work? So remember, this is 58 years ago. So how does Eliza work? It works through pattern matching. So Eliza has around 20 to 30 of these types of patterns. So when I say pattern, there is an input and then it studies the input, finds a pattern, and then Eliza has a set of patterns to match the input with. So this is one example of Eliza's pattern where there is a subject I, a verb want to, and then the object run away from the parents. Okay, so let's say this is the input, the pattern would be subject, verb, and then the object. When Eliza sees this pattern, the response of Eliza would be to convert it into this form. So it would have the canned template what would getting to and then it will append the object, run away from your parent. So the my has been inverted because she's now responding, and then she adds meant to, and then the subject I would be inverted again into you. So the input, if there's an input from the patient, I want to run away from my parents. Eliza would respond with, what would getting to run away from your parents mean to you? Okay, there are, as I've said, around 20 to 30 of these templates in Eliza. So they are simply rules or patterns. Eliza matches them, and then it generates a canned response. So let's say it sees the input, my brother wants to bring my parents to the beach. So using this pattern, it would simply be inverted into, what would getting to bring your parents to the beach mean to your brother? So that's what it is doing. That's what Eliza is doing. Whatever is the input, it checks for a pattern, and then she reverses that input into a response. So aside from the patterns, Eliza also has a set of synonyms. So let's say for want to, they are part of the wish verb. So among those wish verbs would be want to, wanna, intend, wish. So if there's an input that uses any of these verbs, and then it matches the subject verb object pattern, it will be inverted into something like this. Okay. And I think you also saw in that video that when Eliza could not understand the input, meaning there's no pattern for a certain input, it has a set of catch-all phrase, like, or catch-all response, like, can you give a specific way, a specific example to that, or in what way, or could you repeat that, could you restate that? So that's basically how Eliza works. It's basic pattern matching. So the difficult part in building a chatbot that is similar to Eliza would be to come up with all these patterns. So they are human designed, human crafted, and then we program them as a set of regular expressions or if-else statements for those who are programming. So after that, and when machine learning advanced, so this is in the mid 2000s. So Eliza came out in the 1960s, 1960s, 64 to be exact. So come mid 2000, there's a lot of advances in machine learning, and for the chatbot, the work on determining the intent behind an input to the chatbot began, and that was called intent classification. So machine learning was adopted in chatbot applications through the use of an intent classifier. So given an input, the chatbot will try to determine what is the intent behind this input, and then it will give a response based on predetermined responses. So this is how most of the chatbots that we use now work. For those who use Shopee and Lazada and use all the chatbots in the online shops, those online shops would have something like this working. So how does it work? So basically, for an online shop, so it's an e-commerce chatbot, the goal is to first determine what are the possible kinds of inputs from the user. So for Lazada online stores, there would be price inquiries, warranty inquiries, discount inquiries, maybe product inquiries, availability inquiries. Now, once the kinds of inputs have been determined, the developer would have to think of the actual samples of these intents. So these are called intents. So let's say for price inquiries, how do people express those price inquiries? So it could be magkano ba yung whatever the product is, and then how much po. Right now, we use HM na lang, di ba? Or for product inquiry, we might ask, may warranty ba, etc. So for each intent, we come up with a set of possible inputs or sample inputs. And then per intent, it's all still the human doing this. Per intent, we come up with possible responses. So what happens at runtime is given an input and it matches a certain intent, the chatbot will simply get from one of the canned responses that have been predetermined beforehand. So how is this data used? So first, there is training on the intent classifier. So the model that we are creating is the intent classifier. The goal of the chatbot is to determine what is the intent behind an inquiry. So coming from the intent, so this is actually called the category or the known label, and the sample outputs. Together, they form the training data. So to train the intent classifier, we need some machine learning algorithm. So the training data together with the known label, so the training data together with the known label, they are fed to the machine for it to be trained. So the training data, since they are text and the machine does not understand text, it has to be converted into an intermediate format called the word embedding, which is simply a vector of numbers, and that is the representation of the input that is understood by the machine learning model. So it gets trained using the samples once we have the intent classifier trained. At runtime, once we're using it, given an input, it may be something new, never seen by the intent classifier in the training data. For example, the input is may less po ba? This input will again be converted to the intermediate format, fed to the intent classifier. And then the intent classifier will now try to determine or predict what's the intent behind this input. So eventually it would figure out, the less is synonymous to discount, so it is a discount inquiry. So after that, it will simply get the canned responses from the discount intent. So that's how the chatbots that we use now work. So there is a need to come up with the training data. And this training data is actually built. This is actually built by the developer. So we need sample inputs. It may be handcrafted. It may have been taken from some data set. But the important thing is for each training sample, there must be an annotation, and that is the label, the intent. This is required. So, and then from there, the training happens. And then eventually we get the chatbot. Okay, so those are the two main pre-transformer AI techniques used in coming up with a chatbot. So the earliest techniques use patterns or rules. These rules and patterns may be based on the language itself, so they may be linguistically based. They also are based on the domain or the knowledge of the application that's being built. And then since this is very difficult to come up with, when machine learning came about, the goal now is simply to come up with the solution actually now is simply to come up with the training data. So find some sample inputs, label the inputs with the correct intent, and then feed it to the machine for training so that the machine would eventually understand what the input is through intent classification. And then when 2000 came, year 2000 came, we also got the transformer, not the Decepticons and the Autobots. Okay, so then came the transformer. So this is the transformer. This is talk to transformer. So I'm sharing this video here because my very first encounter or exposure to the transformer is with talk to transformer. I think that was in 2018 or 2019 thereabouts. And when I saw this, I was wowed. And my main goal then was to come up with a Filipino transformer because this is an English transformer. So as you could see, that's its power. So what is a transformer? So a transformer is a deep learning model, and it adapts or it uses the mechanism called self-attention. So please take note that the transformer is not the only deep learning model that uses attention. So another deep learning model called the recurrent neural networks, it also has attention. And that attention is what allowed the recurrent neural network to process sequential input data awesomely. So when the RNN came about, NLP work actually bloomed. There are so many problems before that were solved because of the recurrent neural networks. However, what does the RNN do? It provided attention. So what attention simply does is, given a sequence of inputs, it can attend to its neighboring word. So let's say for the RNN, it will find the context of what it is. So it tries to understand what it means by looking at the words around it. So by attending to the words that are before or after it. What made, so if it is RNN, it might see that it is actually related to street, okay, because it is attending to it. All of these happen through mathematics. What transformer did to the RNN is that instead of processing the data in order, which was the limitation of the RNN, for the transformer, order is no longer necessary. So it can now process data without order. It doesn't have to be sequential. So it means that right now the transformer can actually attend or find context to a word, to any word in that input, regardless of its position. So it can be referred to the, can attend to the, to animal, to cross, to street, etc., etc. And then animal could attend to the animal, cross, etc. So each word can attend to all the other words in the input. So what's the effect of that? One effect is that it provided more context, because let's say for the word it again, it can actually be not just the street, it can also be the animal. So if we consider this sentence, the animal didn't cross the street because it was too tired. This it is not actually the street, it is the animal. So with the transformer, the understanding of the words became deeper because it can now see beyond what is neighboring it. So that's one. So order in the input is no longer a limitation, and because of that, it can understand the sentence better. And then second, because order is not important, the processing of the attention of each of the words can be done in parallel. So when we process what animal means, I can process that separately from it, because I don't have to process animal first before it, because because the transformer is attending to all the words in the sentence anyway. So that parallelism drastically reduced the training time while improving the way it is understanding the input. So that's how the talk to transformer is able to generate all these really good, I would say, texts or narratives with just a short prompt. And as you could see as you saw in the video, what it generates is very different. The text that it generates are very different from each other. So this was developed I think this was released in 2018. There are many types of transformers. Talk to transformer is a GPT-2. So there's Bert, Roberta, Ernie, etc. They're all transformers. They all work this way. There's attention, and the attention doesn't need to consider the order of the input. When this came about, I wanted to have a Filipino transformer, and that's exactly what we did at DLSU. So in 2000, the year 2000, Blaze, Jillian, and I used the transformer model to detect fake news. So that's the use case that we did, not to generate text alone, but we use the transformer as a detection system, specifically for fake news. So that was in 2000. And part of that was the creation of a transformer that understands Tagalog. So how did we build the 2000 GPT-2 Tagalog? We took the Tagalog Wikipedia. That's the reason why we call it Tagalog GPT-2 rather than Filipino GPT-2, because the data set was from the Tagalog Wikipedia. But in general, it understands really Filipino. So this language model, the Tagalog GPT-2 2000, was trained on Tagalog Wikipedia. And then using that language model, we fine-tuned it so that it could detect fake news. And then last term, just so I could relate the Tagalog transformers to talk to transformer. Last term, I had a special class. It's about language model. So one of my students, Kenneth Loquinte, his assignment was to come up with a news generating transformer. So what Kenneth did, so he just finished this last January as an assignment. So he took our Tagalog GPT-2, trained in Tagalog Wikipedia, and then use our news PH data set. This is a collection of around 230,000 news articles collected from the web. He used this to train again the Tagalog GPT-2 to equip it to with the knowledge of how news is being written. So it would somehow see the format, the language, so that it would be equipped with the skill to generate news articles. And then just to see the effect of a GPT, a transformer that does not have any knowledge whatsoever of the language, from a bare GPT-2, it's not completely bare because the original GPT-2 is pre-trained in English, so it knows a little of the English language. He pre-trained this using just the news PH. So this is the output. So this is just a small model due to resource considerations, but it is able to generate text. So from a prompt or an input of 3 words, it will generate the rest of the sentence or the rest of the sentence. Um, it gets cut off at some point because the model is small. So the GPT of Talk to Transformer is actually very big. It was trained in billions of articles, while UsePH is only about 230,000 articles. That's why the capability of to generate is also small. But you could see here that the GPT, the transformer, was able to actually generate text that sound Filipino. It is grammatically correct. It is also sensible. Take note, we only fed it with the articles. We did not do anything. We did not teach it grammar. We did not teach it vocabulary, nothing. We just fed it with data that we got from the internet. And the data is not even annotated with anything. And that is its capability. And then we checked also, sabi ko, Kenneth, since there is a bit of English in the news that we collected, and then GPT-2, the bare one, should have some knowledge of English. Can you see if it can generate English? And it did generate English, and it still generate in English, English text, and it still made sense. And then we look for some words that are not really English, and then we found this. I think this is Cebuano, because the news article from which this came from is Cebuano, and it was able to generate. So the Cebuanos in the audience, if you could read this, they said that this really makes sense, and then and also Filipino. You could also see from these examples that what is being generated by the GPT-2 that saw the Tagalog Wikipedia is very different from the the transformer that only saw news. There are some information that can be generated by the Wikipedia knowledge that is not really about news, like the first and the second, actually even the first, the third, and the fourth sample. So that's the power of a transformer. Kenneth built it, I think, in a month using Colab, the Google Colab. So it's a very small model. And if we just had more resources and time for Kenneth, we could actually make this bigger. Okay. By the way, the transformers that we built, Blaze and I built, they're all shared on Hugging Face. You just type Google Tagalog transformers or Tagalog language models, and it will lead you to the Hugging Face page of Blaze, and it is there. We are sharing all these language models to the world because we want to develop more the Tagalog language, the Tagalog transformers. That's one. But we also have an ELIZA transformer that is in Tagalog. So I think 3 years ago in the year 2000 also, Microsoft came up with Dialogue GPT. So this is a transformer that can talk. So it is conversational. Unlike the generic transformer, it can simply generate text, not really talk, not really converse. But Microsoft shared the Dialogue GPT that can converse. So, of course, since it's there, my team also developed this, and this is Tagalog Transformer. You could access it at Tagalog Transformer Me. This is also shared on Hugging. The model itself is also shared on Hugging Face. Okay. Um, how did we build it? So we built this one using the Pinoy Exchange conversation data set. So we collected from Pinoy Exchange, uh, the Pinoy Exchange forums, many posts from the leisure, travel, lifestyle, I think health also, and then use that data to retrain one of the transformers that we have. It's the Roberta transformer. And then using that, we once we have the language model, we trained it again using dialogue, Microsoft's Dialogue GPT. So, can it converse? Actually, it can converse. Kita niyo yung sagot niya. Masarap, masarap din ang milk tea ng mga tindahan sa mga malls. Tapos sumagot ako, ang sarap ng Tiger Sugar. Masarap din ang milk tea. See, it repeats. So it repeats at some point. That's the problem with the transformer. So once it reaches its limit, it just regenerates and regenerates the last output. Okay, so I will stop this. You could access Tagalog Transformer on Transformer.me, Tagalog Transformer.me. When we created the Tagalog Transformer, we just wanted to see if it is really possible to come up with a Tagalog chatbot without teaching it how to to converse. So we wanted to see its power. And then at the first try, we felt na medyo bobo. So it is not as good. Yes, it is coming up with responses. They are in Filipino, but the diversity and the way that it is speaking is very monotonous. It keeps on repeating the same things. And that is because we have so little data. Uh, the all the dialogue GPT based chatbots that are out there, they are trained in billions of conversations, and we didn't have the time to collect that. So what we wanted to do then, the four boys and I, so Denzel, Skylar, Gab, Adrian, and me, we wanted to show how the transformer can actually be used to augment the data. Since the transformer can generate text, why not make it generate synthetic text that we can use as data set to augment the data that we have? And that's exactly what we did. So from the Pinoy Exchange corpus, we got 30%. From that, we use the Tagalog Roberta model. This is a transformer based on BERT. And then we created the synthetic data. How did we generate synthetic data? So first, we use an existing part of speech tagger that we have at DLSU. So we covered. So we made the transformer fill in the blanks. So let's say, given an input from Pinoy Exchange that says masarap ang milk tea, we masked or we covered, we made into a blank all the adjectives. So masarap, mabuti, maganda, mabilis, all of those, we made the transformer fill up that blank. So that yung masarap ang milk tea, pwedeng pinalitan siya it was synthesized into malamig ang milk tea. So that's what it did. All these are done automatically, and we were actually surprised at how well the transformer was able to come up with logical synthesized data. So kunyari, masarap ang milk tea, it never gave us inputs like mabilis ang milk tea, although it knows what mabilis is. It knows the word mabilis and it does understand it, but based on the words that are appearing with mabilis in the knowledge that it already knows, it never attached mabilis with a milk tea. So which is actually amazing for us. And then from there, we use the combined original Pinoy Exchange corpus and the synthesized data, used it as training for the dialogue GPT transformer and came up with the Tagalog GPT. The transformer me, due to ethical considerations, we did not upload on Hugging Face the transformer that uses a lot of the synthetic data. I think the one uploaded only uses about 5% of synthetic data. And we did that because were not, it's impossible to manually check the thousands of synthetic data that was generated. And because of that, we were afraid of what the responses that may come up from Tagalog transformer if it used too much synthetic data. So what we shared on Hugging Face only used, I think, just about 5% of synthetic data, just to be on the cautious side. Okay, just to show you how well the use of synthetic data was. So here are some samples. We gave the same inquiries to the chatbot. At first, we didn't use any synthetic data, and then we added 10% to the data. 10% of the total data set, 10% of the total training data set was synthetic data, and then added 15% synthetic data, etc., etc. You could see from here how the difference, actually, even if you don't read it, the fact that the responses just gets longer, it means more information is being added to the response automatically by the transformer when there was synthetic data that was added. So, di ba amazing? Okay, so now, the limitation of data is also being addressed by the transformer. So the transformer requires data. But if I don't have enough data, I could use the same technology, the transformer, to come up with synthetic data so that the transformer would learn more and it would do its task better. And then right now, so this is the third application. Right now, we are building the Filipino WordNet. So WordNet, this is funded by DOST. You could find more information on this website. So what are we building? It is a database of the Filipino words that you can find on the internet. And these words are related based on its semantic relations. And then we organize the words based on synsets. So we want to group together words that are synonymous. Take note, this is not a dictionary because we are building this automatically using, in my case, using transformers. And then in the group of Dr. Brian Sampson and Eunice, they are using network science. In my case, I am using transformers. This is not a dictionary. It is a database of words, and the words are linked together. They're organized based on their senses or the way they are being used. That's the sense, and on the sense, and then based on synonyms. So to elaborate on this, so let's say the word awit. So we all know that awit is kanta, diba? Pero this is actually what we found on the dataset. So we are using awit in a different form. So para sa iyo ang awit na to, so we understand that. But there's this awit, ang saklap naman nito, and the awit yun, pare. So it turned out that awit is now a coined word. It is the merging of aw ang sakit. It became awit. Okay, so it's a contemporary word. It's very Filipino, and it's these kinds of examples that we wanted to build WordNet because there are so many words now that are not being placed in any of our lexical resources. So how are we doing this? So we are using the transformer to group together those sentences that uses awit with the same sense. So this is the sense of awit that is a song, and this is the sense of awit, which is the aw ang sakit. And we did that using, again, the Tagalog Roberta transformer. So the transformer is used to generate the sense embedding. So we started first with the sentence embedding. So for each sentence, the transformer generated the meaning of this sentence and represented it as a vector of numbers. And then from there, once we have all the sentence embeddings of all the sentences that has the word awit, we clustered together the vectors that are similar and formed that and made that the sense embedding. So we hope when we were conceptualizing this, we were hoping that once they are clustered, the transformer can again generate the embedding for the sense of a word. And it turned out it's actually happening. So after coming up with the sense embedding, we also want to group together words that are synonymous to each other, such as the awit na song sense. We want it to be grouped together with kanta because awit and kanta are the same. And we also do that using the sense embedding of the words, and then we cluster them. So to visualize, dako is actually synonymous to awit, and we wanted them to be clustered together. So as it turned out, we now have around 5 million unique tokens to be processed. And we are indeed discovering new senses, new words, new senses of words. But what is more interesting to us is that using the transformer and clustering, we are able to add to the old synsets of the old Filipino WordNet. So in 2010, also in DLSU, with the team led by Alan Bora, they made the first Filipino WordNet. It is a small WordNet, but it's a WordNet nonetheless of Filipino words. And what we are doing now is from the new senses that we find. So let's say okasyon, nahanap namin si okasyon in the data set. And then we're adding automatically using transformers okasyon into an existing synset from from the Bora Filipino WordNet. So we now have the updated synset na okasyon, pagdiriwang, selebrasyon. And ito, tuwang-tuwa yung mga students ko dito because they learned from this exercise na dati, before, the synset kasintahan is only attached to the nobya. Now, it's attached to the nobyo automatically. Okay, so these are new synsets, that just a few of the new synsets that were updated from the new senses that we found using the transformer. So just to review, there are there are three major techniques in the journey or in the history of chatbot, in the development of chatbot. We started with simple pattern matching. So the requirement then was the handcrafted rules. Then came machine learning and intent classifier. The requirement became labeled training data. So there's still this labeling process that is taking time. Then when the transformer came, we no longer need those labels. We just need enough data for the transformer to learn the language and to learn the task that is being required of it. And as I've shown in the Tagalog transformer if there is not enough data, we can use the same technology to generate synthetic data. Okay. So to close my talk, we've seen the power of transformers. But with power comes great responsibility, as said by Spider-Man. So while there are already many talks on the societal impacts of both positive impact and negative impacts of AI, what makes the transformers unique is that it does not only automate human processes like the other AI techniques does, but it is also able to create. And that is a capability that was used to be reserved to humans. So, and because of that ability to create, it leads to a lot of things to be to think about. And I will start with the first three. So the first effect is the difficulty in scoping all the possible uses or misuses of these large language models. Though they are general purpose, they may be used in a bad way. Actually, this is one of the main reasons why when we share the models, we are only sharing the general purpose language model, and that is the Tagalog or Filipino transformer. It is now up to the person using it to determine how in what way will it be used for good? Kasi, di ba, there's a saying, in every seed of good, there will always be a piece of bad. So, actually, that is a big problem. For me, that is a main consideration. I want this technology to develop in our languages, but how do I set the boundaries so that it won't be used or it won't be misused? It would not be misused. And it's very difficult. So that's why, even though there are more models in the lab, uh, I don't want the students to be sharing them because of how they might be misused. Second is the potential of these models to algorithmically spread disinformation. I think you saw this in the News PH transformers. Diba? News PH GPT is got some information from this article, and they get some information from this article, and then he aggregated it, and then eventually it was able to generate an article, which is not necessarily true, right? So there is that danger. And this is also why we are not coming up with the model that actually, we are not sharing. We are not sharing models that actually generate very long text because of this big consideration. And third is the difficulty in mitigating the model's bias, whether it be racial, gender, or religious bias. Uh, in reality, all data sets are biased in some ways. So the challenge is not in eliminating all the biases because that is impossible. If you eliminate all the bias, maybe there's nothing left in the data set. So what is important is we address the harmful biases that are present in the data set according to some set of ethical, moral, and legal criteria. However, even if we have these criteria, they may not be easy to enforce, which is why it is very difficult to mitigate biases that are present in the model. And lastly, is the effect of this very powerful model-based automation on the labor market. I only showed you two applications of the transformer, and that is the chatbot and used as a text generator. But the transformer is being used in our laboratory for translation, for detection, for classification, and for summarization. And I'm sure there are other people who are using it in different other language tasks. As these models continue to improve, they will also get better in automating processes, human processes, including creative tasks done by only humans before. Eh, while I always maintain that the human will never be, that humans will never be totally replaced by robots, just like we still have human bank tellers despite the presence of ATMs. It is a reality that the number of bank tellers now are lessened due to the ATMs, right? So there will be a big effect to the creative and the artistic market. Actually, in all the markets that are addressing that whose tasks are based on language or jobs that are language based. And there is also this concern on differentiating what is real versus what is synthetic. I always use the word synthetic because yung word na fake has been so abused. So what the transformer is generating is synthetic. It's not really fake. Okay, so but there's that concern. It's now so difficult for us to differentiate what is really real, meaning created by humans, and what was synthesized, meaning created by robots. Consider the ability of Talk to Transformer, and it could write so nicely written essays, even better than the essays that I could write, right? So, um, how do we differentiate it? And as these models continue to develop, as more human tasks and abilities are being simulated and automated, these concerns will just be more magnified. And so, yes, it's true. Many problems are indeed being solved, and they are solved magnificently by this technology. However, the line between human created and machine created becomes more and more blurred. So with that, I end my talk. Thank you very much.